take a look at another problem. Jacob needs 2 strips of wood to make masts for miniature sailboat. One mast will be 3 6-foot long. The other mast will be 2 6-foot long. He has a strip of wood that is 4 6-foot long. Is the strip of wood long enough to make both masts? So I'm understanding that Jacob has a miniature sailboat and he has 2 masts that he's making. One mast is 3 6 feet long and the other is 2 6-foot long. And he has a piece of wood already that is 4 6-foot long, and he needs to know if that piece of wood is long enough for both of the masts that he needs to make. You could use fraction strips like we did before to solve this problem. Try pausing the video here and seeing if you can use fraction strips to solve this problem. Then start the video to see a different strategy. So hopefully you gave that a shot. And now let's take a look at another way that we could tackle this problem. We could draw a diagram or a bar model to help us solve. So I'm going to start by drawing myself a rectangle. And then I'm going to split this rectangle into 6 parts because all of the fractions that I'm working with in my problem have a denominator of 6. And to do that, I'm going to first start by splitting it as close to the middle as I can. It doesn't have to be perfect because this is just a diagram for myself. And then I'm going to split each of those halves into 3 pieces by drawing 2 lines. So I'm going to do that on this side as well. And now I have a rectangle that has 1, 2, 3, 4, 5, 6 parts that are pretty equal. Again, they're not perfect, but that's okay for our case right now. Next, what I'm going to do is I'm going to use this model to help me figure out how much wood Jacob needs in total. So I know that one mast will be 3 6-foot long. So I'm going to shade in 3 6. Here's 1, 2, and 3 6. And I know that his other mast is 2 6-foot long. So I'm going to shade in 2 6 here. And that helps me get to the equation of 3 6 plus 2 6 for a total of 5 6. Now what I need to do is I need to figure out if that 4 6 piece of wood is long enough for what he needs. Is it enough? And I can do that by drawing myself a quick number line above my bar model. I'm going to do that by drawing a line across the top. And I know that over here where my rectangle starts, this would be 0, and where it ends over here would be 1 hole. And along the way, I know that each mark on my number line will match up with the marks of my rectangle, and I will count up by 1 6. So now I've got my number line that's labeled from 0 to 1, counting up by 1 6 as I go. I know that I need all the way up to 5 6, or this last shaded section of my model for both masts. But I see that the amount that I have is 4 6, and I can use my number line to see that 4 6 falls right at that point where I drew that line. And so that tells me that Jacob needs more than what he has. He only has 4 6, but he needs more than that. So using this number line helps me compare 5 6, the amount that I need, to 4 6, which is the amount of wood that I have. So I can say that no, this strip of wood is not long enough for both masts. Let's practice this strategy again with another problem, 3/8 plus 3/8, and we're looking for the sum of those two fractions. We're going to do that by drawing our own diagram. I'm going to start by drawing a rectangle and splitting it into 8 equal pieces since our fractions have a denominator of 8. I'll split my rectangle in half to get 2 pieces. I'll split each of those halves in halves to get 4 pieces, and then again one more time splitting each section in half to get a total of 8 pretty equal-sized pieces. Now what I'm going to do is I'm going to start shading and labeling my rectangle. I know that my first fraction that I'm working with is 3/8, so I'm going to shade in 1, 2, 3/8. And my second fraction is 3/8 as well, so I will do the same thing, shading in 3 pieces, 3 1/8 size pieces. And then I can use that to write my equation, which is 3/8 plus 3/8, which we see is a total of 1, 2, 3, 4, 5, 6/8. And you might be thinking that 6 and 8 have a common factor, which is 2, and you are absolutely correct if you're thinking that. So I can simplify this fraction by dividing by 2 to get 3/4. I could even prove that 3/4 is equivalent to 6/8 by drawing a quick sketch. I'll draw a 1 hole that's the same size as my hole that I used for my 1/8. I'll split it in half to get 2 pieces, and then in half again to get to a total of 4 pieces. And then I would need to shade 3/4 because that's the fraction I'm claiming that is equivalent to 6/8. And when I do that, I find when I shade 3 out of my 4 sections that it is equivalent. So today we used fraction tiles and bar models to add equal-sized parts of a whole, meaning fractions with like denominators.